Hey, I am Chen and I'm glad to present our paper Imitation of Life, a search engine for biologically inspired design. Joining me as co-authors are Nadav Bronstein, Sink Yang, Hon Suk Hang, Joel Chan, Nikki Kitter, and my advisor, Daphna Shachaf. So, what is biologically inspired design? Biologically inspired design, or BID for short, it's a problem-solving methodology that applies analogies from nature to address engineering challenges. However, BID is not a new concept. Throughout history, nature has been a driving force for innovation. Consider the case of Leonardo da Vinci, who drew inspiration from bat wings in his visionary attempt to create the first flying machine. In a more recent example, Speedo engineers mimicked Charles' skin to design a swimsuit that minimized water friction, enhancing swimmer speed. Despite the potential of BAD, its widespread application faces several challenges. Engineers, while adapting their own fields, often lack the deep biological understanding required for effective BID. This gap hinders the integration of biological insights into engineering solutions. Moreover, finding the right biological inspiration can be like searching for a needle in a haystack. The scarcity of accessible and relevant information make it a time-consuming process that often relies on serendipity. While there are few datasets available for BAD, they are manually collected and thus small, and expanding these datasets through costly human annotation becomes a bottleneck for wider adoption. The challenges in knowledge gaps, information scarcity, and dataset limitations lead us to the conclusion that BID can and should be automated. Now let's define a problem. Given a corpus of documents written in natural language, imagine that a user, an engineer or designer, inputs a challenge they have. For example, collect water from a midair. In response, the system provides a list of sentences, ranked in order of relevance. These sentences serve as potential sources of inspiration. More specifically, we are looking for sentences describing an organism facing a similar challenge to that of the engineer, like trapping moisture, and potentially the strategy it uses to overcome it. In our work, we present BARcode, Biological Analogy Retrieval. It's a scalable and automatic end-to-end system for mining bioinspiration from unstructured data. It's designed for engineering designers, and it can handle any large corpus. As a proof of concept, we use Wikipedia in our work. Our system has three components, with the first being optional. We use Snorkel, a data programming tool, to create a speed-up version of the system. We define filtering heuristics to identify sentences with potential bioinspirational information. For example, we assess whether a sentence includes an auxiliary verb, which is a cue that the sentence contains challenge and strategy. This process significantly reduces the dataset size without compromising performance. For more details and results, see our paper. Then, regardless of whether the data is filtered or not, our process involves two phases. At first, we go over sentences to find phrases that potentially can be matched with the engineer's challenge. Take, for example, the challenge of trapping moisture using strategy of leaves covered by an oily coating. To extract potential phrases, we use two NLP techniques. One of them is QSRL model. The model takes as input a sentence and generates questions and answers about the verbs in it. For instance, what does something trap with an answer, moisture. We then combine the verb and the answer to create candidate phrases. QSRL has some limitations, especially with phrases containing auxiliary verbs. To overcome this, we turn to a second technique, dependency parsing. It provides more flexibility, allowing connection between non-adjacent verbs and objects. This enhances our ability to capture a broader range of challenge-related phrases. Moving to the second step, we match the user query with the candidate phrases we extracted earlier. For this task, we employ two models. We begin with sentence embedding model to assess their semantic similarity. In addition, we use natural language inference model as it helps handle words with opposite meanings, like increase and decrease, something the sentence embedding model struggles with. Moreover, it captures relations of causality on common sense, such as stay moist and reduce water loss. This improves the matching process, adding nuanced connections between the query and the candidate phrases. We evaluated our system retrieval quality in 3 ways. At first, we compare our method to a search engine, which is the most likely tool to be used by people looking for bio-inspiration today. We gathered 42 queries describing engineering challenges and collected the top 15 results per query from BARcode and this baseline for both settings, the entire data and the filter data. We used crowdsourcing to determine whether each sentence contains a challenge similar to that of the engineer and/or a strategy to tackle it. We evaluated the results using 2 information retrieval metrics, precision at K and NDCG at K. And now for the results. We show that BARcode substantially outperforms the baseline, both for the entire data and the filter data for both metrics. In the left figure, precision is represented on the y-axis, and the rank of the results on the x-axis. As we can see on the left part of the plot, the system is better in identifying sentences with challenges relevant to the engineer's problem, and on the right part of the plot, in retrieving potential strategies. We show that BARcode can provide inspirations from nature to a large variety of queries, and that the filtering heuristics drastically reduce the data volume before performance starts to decline. Next, we decided to challenge our system by looking for inspiration behind 5 famous BAD applications. Our system successfully retrieved the inspiration of 4 out of 5 applications. As an example, consider the Speedo swimsuit designed for faster swimming. To test whether our system can help solve real-world problems, we asked 3 engineering experts to use it. They tried to find ideas that could help with their specific research problems. 21 of the generated inspirations were ideas that the expert had already considered. This shows the system's ability to suggest relevant inspirations. 6 out of 5 searches resulted in at least 1 unexpected and highly interesting inspiration. This demonstrates the system's capability to provide novel and valuable insights. Additionally, we applied ChatGPT to our problem. However, we observed that it tends to hallucinate facts, making it hard to trust, and noticed that it has limited coverage, resulting in repetitive information within the top 15 results. To conclude, biologically inspired design drives innovation. Here, we present BARcode, a flexible search engine that automatically mines bio-inspiration from unstructured data. BARcode extracts valuable inspiration, including historical examples, and it provides valuable insight for real-world engineering problems. We see BARcode as a step towards addressing the challenges that historically hinder the practical application of BAD to engineering innovation. Thank you for listening. See you in Vancouver.